Okay, so we're going to go ahead and continue with our problems. We had left off on question 25, which is a graph of tangent. Okay, so now we are on question 26. And we have, these are going to be relatively quick. Here we're going to be evaluating trig functions using the unit circle. 5 pi over 4. Let's go ahead and grab the unit circle. So we want to do 5 pi over 4. So to use the unit circle, what we're going to do is look for, let's get my pen here. What we're going to do is look for 5 pi over 4. So here's pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, aha, 5 pi over 4. So on the unit circle, 5 pi over 4 lands us here. It's also 225 degrees. Now we're evaluating cosine. You want to look at the x from the coordinates. You have an x and you have a y, right? You want to look at the x. Cosine is equal. Cosine of 5 pi over 4 is equal to the x here, which gives us negative, that's negative root 2 over 2. So we basically come back over here, and this is equal to negative root 2 over 2. And that's all you have to do using the unit circle. Relatively easy. You have to memorize this, so that's going to be an important component of your mathematics education. Let's go ahead and try question 27. So this one has sine of 5 pi over 4. So now it's sine of 5 pi over 4. Well, guess what? We hop over to the unit circle. We see 5 pi over 4 lands us the same spot over here. This time they want sine. So sine is the y. So that's negative root 2 over 2. So here we write negative root 2 over 2. And that's it. Alright, cool. So 28. This one wants sine of 5 pi over 6. This is equal to, same thing, go to the unit circle. We go ahead and find 5 pi over 6 on the unit circle. That's right here, 5 pi over 6. And we're looking at sine, so we want the y value. So remember, you have coordinates x and y. The y is 1/2. So sine of 5 pi over 6 equals 1/2. And that's it. You're done. Question 29. We have cosine of 5 pi over 6. So now it's cosine of 5 pi over 6. So where's 5 pi over 6? Right here. Now we're dealing with cosine. That's the x. So that's negative root 3 over 2. And that's it for 29. Now question 30. This one is tangent of 5 pi over 6. So to do tangent of 5 pi over 6, we can use the unit circle. Remember, tangent is sine divided by cosine. Here's 5 pi over 6. Our sine is 1/2 and our cosine is negative root 3 over 2. So we have to do sine over cosine. That's important. So it's going to be 1/2 divided by negative root 3 over 2. We can convert this into 1/2, so elementary kindergarten fractions here. 1/2 times negative 2 over root 3. This cancels, that cancels, so then we get negative 1 over root 3, which is also negative root 3 over 3, simplifying the radical. Okay, so we have that. That's question 30. Now we're on question 31. Oh gosh. Oh, okay. Okay. So on question 31, They want us to find tangent of 2 pi over 3. We come to the unit circle. We look for 2 pi over 3. Where does that? That's right here, 2 pi over 3. We want to do tangent. So that's the y divided by the x. So I'm going to go ahead and do that. I'm going to just write it down real quick. Tangent of 2 pi over 3 is equal to y divided by x. So that's root 3 over 2 divided by negative 1/2. That's going to give us root 3 over 2 times negative 2 over 1. That cancels, so we get negative root 3. Alright, very nice. Now we're on question 32. So here we have cosine of pi over 3. Again, using the unit circle. Cosine of pi over 3, here's pi over 3 on the unit circle. Cosine is the x, so that's 1/2. So the unit circle is kind of like your multiplication tables, right? You get an angle, and then it's going to say sine, cosine, tangent, or any trig function, and you use these coordinates to find the value. So in a certain sense, it is kind of like your multiplication tables. You have to memorize it like your multiplication tables. Alright, so we did cosine of pi over 3, good. Question 33. This is sine of pi over 3. So once again, like multiplication tables, pi over 3, sine is root 3 over 2. So we just copy root 3 over 2 and you're done. Question 34. Here we have cosine of 3 pi over 4. Again, we go back to the unit circle. We're doing cosine of 3 pi over 4. So where's 3 pi? Aha, there it is, 3 pi over 4. We're doing cosine, so that's the x right here. That's negative root 2 over 2. So this is negative root 2 over 2. Question 34, now we have question 35. Okay, so now we're dealing with trig identities. This one says sine squared of theta plus cosine squared of theta equals 1 is a foundational trig identity. If you divide through by blank, then 1 plus cotangent of theta equals cosecant of theta will be created. Okay, so what do they want us to do here? If you divide through by what? Well, that says sine, so if we divide everything by sine squared, then you're going to get, let's see, yeah, you're going to get 1 and then cosine squared. Yeah, so you can divide everything by sine squared. Yeah, so for question 35, the first blank is dividing by sine squared. If you divide everything by sine squared of theta, you're going to go from sine squared of theta plus cosine squared of theta equals 1 to 1 plus cotangent squared of theta plus equals cosecant squared of theta. And then for the other one, it's going to be you divide by cosine squared of theta. So the other blank is cosine squared of theta. You can do the math there and see what happens if you divide the first equation. If you divide the first equation by cosine squared, you'll get tangent squared plus 1 equals secant squared. Alright, good. That's question 35. Question 36. Alright, now we get to some fun trig stuff here. So this is cosine of theta times tangent of theta times cosecant of theta. So what I like doing is writing things in terms of sines and cosines. So instead of writing times tangent of theta, we're going to write times sine of theta over cosine of theta times cosecant of theta, we know is 1 over sine of theta. So now we just simplify. That crosses with that, that crosses with that. So we get 1. So our answer is 1. 436. 437. So we want to simplify sine of theta plus cosine theta times cotangent theta. So that's cosine theta times cotangent theta is just cosine theta over sine theta. So then this is going to be, this simplifies to sine theta plus cosine theta times cosine theta is cosine squared of theta over sine theta. Now we can get a common denominator. We're going to combine these as fractions. So this is like over 1. Our common denominator, we're going to have to multiply by sine theta over sine theta. So then we end up with sine squared theta plus cosine squared theta. All of this is going to be over sine theta. Okay, so it's just elementary combining fractions. And then we know sine squared of theta plus cosine squared of theta. This numerator is just 1 from our Pythagorean identities. So that's 1 over sine theta. And we know that that is just cosecant of theta. So that's our answer for 37. I'm going to do 38 on this side. So for 38 it says, which of the following is a correct simplification of blah blah blah, which of the following is a correct simplification? Okay, so we're just going to simplify that. So let's see. Let me write the fractions here real quick. So we have 1 plus cosine theta over sine theta plus sine theta over 1 plus cosine theta. Okay. Let's see. What can we do here? So what I'm seeing is you might want to combine these into one fraction. Combining these into one fraction would be helpful. Let's go ahead and do that. So to do that, we're going to be multiplying the numerator here by 1 plus cosine theta. So this is going to be 1 plus cosine theta times 1 plus cosine theta. And it's going to be over 1 plus cosine theta times sine theta. And then plus, and then on this side we have sine squared theta. And then divided by 1 plus cosine theta times sine theta. Alright, so that's our first step here. I'm going to move the camera so you can see a little bit better there. So it's a bit unclear. Alright. So let's go ahead and continue here. So when you FOIL this out, we're going to FOIL the numerator here, this part. I'm going to do 2 steps in one. FOIL the numerator and then add it into one fraction with the numerator here. So when you FOIL the numerator, you're going to get 1 plus 2 cosine theta plus cosine squared of theta plus sine squared of theta. All of this is divided by 1 plus cosine theta times sine theta. Now we know this part, cosine squared plus sine squared, we know that's 1. And then we can add that to the 1 over here, so that's going to give us 2. So we get 2 plus 2 cosine theta over sine theta times 1 plus cosine theta. And you can factor out a 2 from the numerator here. So you're going to get 2 times 1 plus cosine theta over sine theta times 1 plus cosine theta. Then this cancels with that, and we get 2 over sine theta, which is just 2 cosecant theta using our reciprocal identities. So this one is 2 cosecant theta. To the back side here. So that one was question 38. Now we have question 39. Let me adjust the computer. Do it here. Okay. So question 39. Alright, so here we have cosine squared of theta plus cosine squared of theta times tangent of theta. Sorry, tangent squared of theta, that's what I meant to say. So the first thing we're going to do here is let's go ahead and rewrite this using the identity for the tangent, because remember that tangent is sine over cosine. So we have cosine squared of theta times sine squared of theta over cosine squared of theta. And this is over 1. Alright, cool. So now we have that using our identities. This cancels with that. So we're left with cosine squared of theta plus sine squared of theta. We know that that is just 1. So the answer here is 1. So now we have question 40. So we're going to simplify cotangent theta over cosecant theta. Okay, so we know cotangent theta is cosine theta over sine theta. And this cosecant theta, you can bring it as sine theta on the top. It's one of our reciprocal identities. Cosecant of theta in the denominator becomes sine theta on the top. This cancels with that. Answer is cosine theta. You're done. That was easy. Now we're on 41. So this one has sine squared of alpha over 1 minus cosine of alpha, and then minus 1. Okay. So what I'm going to do first is common denominators. So sine squared of alpha over 1 minus cosine of alpha minus this 1, I'm going to rewrite it as 1 minus cosine of alpha over 1 minus cosine of alpha. I just rewrote the 1 there. Now I can go ahead and see common denominator. Wait, maybe this won't help us. Hold on. Sometimes when we're simplifying, we end up with expressions that don't actually help us at the end. So hold on, let's see, this looks like this might. No, we're fine. We're okay. It just might look kind of weird. You know what? I got a better idea. Instead of doing the minus 1 part, I'm going to leave that as minus 1. Let's multiply by the conjugate. I think that's easier. 1 plus, we won't get a messy expression there. So sometimes you have to kind of, it's like a little puzzle when you do this, so sometimes you have to kind of step back a moment and retry something else. So here we have multiplying by a conjugate, so we have 1 plus cosine of alpha in parentheses times sine squared of alpha, like that. All of this is divided by 1 minus cosine squared of alpha. We still have minus 1, by the way. We just pretend like we didn't do anything to that minus 1. So it's kind of just left it hanging out there. Okay, so the reason why I multiply by the conjugate, look at this. The denominator here is 1 minus cosine squared of alpha. We know that the Pythagorean identity, I'll go ahead and write it up here, is sine squared alpha plus cosine squared alpha equals 1. If you move the cosine over here, then you get sine squared of alpha equals 1 minus cosine squared of alpha. So you can substitute 1 minus cosine squared of alpha with sine squared. So this is now 1 plus cosine of alpha times sine squared of alpha all over sine squared of alpha minus 1. So the nice part about this is that the sine squared cancels with the sine squared. So now we're left with 1 plus cosine alpha minus 1. This 1 and the negative 1 cancel. Answer is cosine alpha, and that's it. Pretty cool. Well, that's question 41. Let's do 42. So this one has sine theta equals root 3 over 2. We're trying to find the numbers for theta. So here we are going to be using our unit circle. Sorry, my audio thing got stuck here. Hold on. Okay. Sorry, the cable got stuck, so I couldn't move my head over here. My headphones are like, they're like strangling me. Okay. Anyway, so here we're trying to find theta. So we're going to use the unit circle. This time, we're looking at the y values and we're finding the angles. And I notice all our angles in this problem, all the angles are in radians. So we're going to be looking at the radians. So we're looking for when when sine theta equals root 3 over 2. So if you're looking at the unit circle, sine of theta is root 3 over 2 when theta is pi over 3. So we already found one. So one of these is theta equals pi over 3. But on the unit circle, there are multiple values. So let's go ahead and find the other one. Where else is sine of theta equal to root 3 over 2? Well, if you come to this side of the unit circle, you have sine is root 3 over 2 when theta is 2 pi over 3. So that's our second value, 2 pi over 3. Of course, if we look at the unit circle, if we're going basically from 0 to 2 pi, we know sine is only positive up here from 0 to 180, 0 to pi. So we already found the two values. There are no other values over here because these are going to be negative for sine. So that's it. We found our two values of theta. There could be more if the unit circle is allowed, like if you're allowed to go to 2 pi and then another 2 pi to 4 pi, then you would have another two solutions hiding there. So it's a little bit trickier, but your problems don't have anything like that. Alright, so question 43. So here we have cosine of theta is equal to root 2 over 2. Now we're just going to find the values of theta. So theta is, we want to find what cosine is root 2 over 2. So that happens here because the x is root 2 over 2 when theta is pi over 4. So what happens when theta is pi over 4? But it also happens when theta is 7 pi over 4. Because remember, we're looking for cosine of theta equals positive root 2 over 2. That only happens on the unit circle. That only happens here and down here. Cosine's negative over here, so we don't look at that. So we got our two values. We said pi over 4, comma, 7 pi over 4. It's actually really easy. It's like it really is like learning your multiplication tables. Okay, so now we have question 44. So here we have tangent theta equals root 3 over 3. Okay, so that one's kind of tricky because root 3 over 3, you can, in a sense, you can unrationalize it. This is really 1 over root 3. Okay, it's like if you take 1 over root 3 and you rationalize the denominator, you get root 3 over 3. Now, why did I do that? Well, I did that because the tangent's always a weird one. The tangent is the one that's sine divided by cosine. When you take the y and you divide by the x, you want to get 1 over root 3. So going to the unit circle, we need to figure out when does that happen. Well, you notice that the easy way of thinking about it is we have root 3 on the bottom. So what that tells us is that we need to be dividing by something that has root 3 on the top. So we need our cosine to have root 3 on the top. So where do you see here where cosine has root 3 on the top? Aha, because remember cosine's the x. So it happens at pi over 6. You see 1/2 divided by root 3 over 2 is 1/2 times 2 over root 3, which is 1 over root 3. So, in other words, we're trying to find any points on the unit circle where cosine is root 3 over 2 and sine is 1/2. Now remember that this whole fraction is positive. So you can find points here, because these will all give you tangent that's positive, because if positive divided by positive is a positive. But then also in quadrant 3, a negative divided by a negative is a positive. So any of these values work as well. So we know here tangent of pi over 6 gives us 1 over root 3. And then over here, so let me write that. So theta, we already found one. Theta equals pi over 6. The other one's going to be in this quadrant. And remember, we want the cosine to have the root 3 over 2. That happens here. So it's 7 pi over 6. Alright, that takes care of that one. Now we're at question 45. So that one's always a little bit trickier, the tangents. Question 45 says, oh, that's easy. Cosine of theta equals 0. So you want to find theta equals what? Again, unit circle. Cosine, when is x equal to 0 in the unit circle? Up here. X is 0. That's at pi over 2. X is also 0 down here. That occurs at 3 pi over 2. Right here. So this happens at pi over 2, comma, 3 pi over 2. And that's it. So we're on question 46 now. Question 46. That one says tangent of theta equals -1. Let's find theta. This is the easy one of tangent, because the tangent is normally difficult, but if tangent equals 1 or -1, that just tells you that the y and the x need to be the same. That only happens here, over here, down here, and over here. The only difference is the signs, right? So in our problem, tangent is -1. Tangent is negative in this quadrant and in this quadrant. Okay? So we're looking here at 3 pi over 4 because our y and our x are the same, except that one's negative and the other one's positive. When you divide them, you're going to get -1. Analogously, at 7 pi over 4, this is positive, this is negative, and this one's positive. When you divide the two things, they're going to be -1. So our two angles are 3 pi over 4 and 7 pi over 4. Okay. So for the next one, we're going to solve a trig equation. So it says cosine of theta times cosecant of theta minus 2 cosine theta equals 0, and we're going to solve. Alright, so cosine of theta, we know cosecant of theta is 1 over sine. So cosine times cosecant. This is easier, okay. Well, never mind. Pretend I didn't say that. It's true, but it's not particularly helpful here. Whenever you see a trig equation, always try and see if you can factor anything in the beginning. This has cosine theta here. This has cosine theta, so you can factor a cosine theta. Always try and factor, especially if it's equal to 0. So cosine theta, and then here we have cosecant of theta minus 2 equals 0. Okay, that's nice. Now we can use a zero product property from algebra. So now we have cosine theta equals 0, and then cosecant theta minus 2 equals 0. We're just using zero product property. Now we're solving for theta. Here we just figured out when cosine of theta is 0, right? It's when theta is pi over 2 or 3 pi over 2. Again, we're getting this from the unit circle. Pi over 2, cosine of pi over 2 is 0. Cosine of 3 pi over 2 is 0. So we have two solutions here. Two solutions. And then on this side, we're going to solve. So this is cosecant of theta equals 2. Remember, cosecant is 1 over sine. So you cross multiply, you can get sine of theta equals 1/2. Now the question is, alright, when is theta? When you plug into sine of theta, when do you get 1/2? Well, that happens when theta is pi over 6, because the y is 1/2. And it also happens when theta is 5 pi over 6, because the y is 1/2 over there. So this is pi over 6, comma 5 pi over 6. And these are the four solutions that we get. Alright, so we have four answers there. Now let's do question 48 over here. Okay, so this one has -2 sine squared theta plus cosine theta plus 1 equals 0. So the first thing we want to do is, this almost looks quadratic. There's a sine squared and a cosine. Let's convert the sine squared. If you see that in an equation, try converting that into cosine squared using Pythagorean identity. The one that we have written right here. This one. We're gonna see sine squared is equal to 1 minus cosine. So let's go ahead and do that over here. So we're gonna have -2 parentheses 1 minus cosine squared of theta plus cosine theta plus 1 equals 0. Alright, very nice. Now we can distribute the -2. So we get -2 plus 2 cosine squared theta plus cosine theta plus 1 equals 0. Alright, cool. Now we can combine like terms. So we have 2 cosine squared of theta plus cosine theta. -2 and positive 1 give you -1, so a -1 equals 0. Now we can factor this. Okay, so when you factor, remember you do this stuff. So 2 times -1 is -2. And then the 1 in front of the cosine is here. Then you have to think, okay, two numbers and multiply them together, give you -2, add them, give you 1. That's -2, that's positive 2 and -1. So now you factor using the grouping method. So 2 cosine squared theta plus 2 cosine theta minus cosine theta minus 1 equals 0. So you can group the first two terms. So you pull out a 2 cosine theta, and then you're left with cosine theta plus 1. Over here you can factor out a -1. So you have cosine theta plus 1 equals 0. Then we can factor the final form here. So that's cosine theta plus 1 times 2 cosine theta minus 1 equals 0. And then now we can do the zero product property. So here we have cosine theta plus 1 equals 0. 2 cosine theta minus 1 equals 0. On this side we get cosine theta equals -1. So we get theta equals, well, when does cosine of theta equal -1? It happens only when theta is pi. Right here, x is -1. So theta equals pi here. And then on this side, add 1, divide by 2. So cosine of theta equals 1/2. When does that happen? That happens when theta equals, let's go to the unit circle, right here. Cosine is 1/2 at pi over 3, and then it happens again all the way down here at 5 pi over 3. So we have pi over 3, comma 5 pi over 3. So we have three answers here, these two and that one. Alright, so now we have question 49. This one is another trig equation, cosine theta plus sine theta times tangent of theta equals 2. Okay. Alright, so let's see. trying to see what the easiest approach here is. Let's see. So we have. So this one is cosine plus sine times tangent. Well, that looks like. Let's see. It looks like we're gonna have to. Okay. So let's go ahead and use our reciprocal identity because we don't like having a sine and a tangent. Let's rewrite that as tangent is sine over cosine. So this is just sine squared of theta over cosine of theta equals 2. Then you can combine these two fractions. So we're going to multiply this by cosine theta over cosine theta. So now we have cosine squared of theta over cosine of theta plus sine squared of theta over cosine theta equals 2. When you add them together, you get cosine squared plus sine squared is 1 over, and then cosine theta equals 2. Okay, so now you just do a proportion, so you're going to get cosine theta equals 1/2. You multiply by that, divide by 2, you get the drill. This is kindergarten. Alright, so now we just have to find theta when cosine of theta equals 1/2. Unit circle. And we want to find cosine is 1/2, so that happens when is x 1/2? Right here at pi over 3, and then it happens again at 5 pi over 3. So theta is pi over 3, comma 5 pi over 3. Two solutions. And then the last one is question 50. Question 50 is funny. So we have a nice triangle here. X, this is 7, this is 4. You want to find the value of x, so you have to use the inverse tangent. So it looks like this. You're going to use tangent of x equals opposite, which is, oh wait, not tangent. It's opposite and hypotenuse, so it's sine. So sine of x equals opposite, which is 4, over hypotenuse, which is 7. Now to solve this, you have to use the inverse. So sine inverse of sine of x is x, and then you get, on this side, sine inverse of 4 over 7. And you get x equals, now we just plug that in the calculator. So in yours, you're going to press the second button, and then you press the sine button, and you're going to get the sign with a little -1. That's the sine inverse. And then here we have 4 divided by 7, close parentheses, enter. And we get 34.8. It wants you to round to the nearest degree, so that's 35 degrees. Alright, cool. 35 degrees. Okay, awesome. So I'm going to go ahead and upload this video as well.